didn't see you there. That lock's harder to pick than most. Oh, great, you already have a gun. No, come on, we're gonna use it in today's experiment. Come on, let's go. It's gonna be fun. Come on. Conservation of momentum. It makes sports like golf, tennis, racquetball possible. It powers the game of marbles, which apparently I'm not very good at. It's even at work in air hockey.
Guys, he said air hockey, not bear hockey.
Now what's this conservation of momentum? How do we apply it? We'll find out today.
A 10-gram bullet is fired into a 5 kilogram stationary block of wood. The bullet embeds into the block. The speed of the bullet plus wood combination immediately after the collision is 0.6 meters per second. What was the original speed of the bullet?
So what exactly are we doing here? Well, let's take a closer and slower look at the problem. So, we fire a bullet from a gun. What a lovely picture. And we'll call that point 1. Now, at point 2, the bullet embeds into the block of wood. And the block is knocked back slightly by the force of the bullet. Now, knowing the speed at which the block moves backward, and knowing the masses of the bullet and the block individually, we can find the initial velocity of the bullet. How? By using the conservation of momentum. But what exactly is momentum? Well, momentum is a quality possessed by matter in motion. Whenever an object is moving, it has momentum. And momentum is defined by an object's mass multiplied by its velocity. Now let's take a look at a marble and a ping pong ball, for example. Now if we set both of these to roll down this hill,
I don't know.
which is going to do more damage to the Lego walls?
Crazy?
Well, let's see.
No! Ow.
The marble did more damage.
I hate you.
Why? Because it has more momentum. Now let's consider a car crash. When the first car crashes into the second car, does the second car stay put? Unless it involves a motorcycle hitting a big rig. No. The second car moves. But where does that motion come from? Well, some of the first car's momentum is transferred to the second car. And that transfer follows the law of conservation of momentum, which states that the total momentum of both objects at point 1 equals the total momentum of both objects at point 2. Let's apply this to our problem. At point 1, only the bullet is moving. And we define its momentum as its mass multiplied by its velocity. And I'll use the I'll use the subscript B to denote bullet. Now at that point 1, the block of wood isn't moving at all. So its momentum is 0. At point 2, the bullet has embedded into the block of wood. So they are moving as one object. So we combine their masses. Mass of the bullet plus the mass of the block of wood. And we multiply that by the velocity that the block is moving at. Call that VW. Now, we are given some information to start with. The problem tells us that the bullet is 10 grams. It also tells us that the block of wood is 5 kilograms. And we know that the block of wood moves with a speed of 0.6 meters per second. So we can start plugging in values to the problem. We get an answer of 301 meters per second. That's the velocity that the bullet was initially moving at. Great. So we know how the problem works. We know the physics behind it. Let's go out and actually do it. Alright, here we are out west of town, and I'm standing here with former Commander Steven DelTour.
Hi Scott, good to see you.
And he's seen 34 years of service.
Thank you.
And he's here gonna be telling us about these guns that we'll be shooting with.
Okay, are we ready?
Mm-hmm.
Okay. Well, we have 3 weapons here today that we're going to fire. And I'm going to start with the oldest. This is a Colt Trooper 357 Magnum. I actually carried this gun on duty beginning in 1971. The second gun I'll show you is a Smith & Wesson 9mm auto semi-automatic. It's got a 4-inch barrel. It's actually a stainless steel model. The third gun we have today is probably my favorite. This is a Glock 40 caliber, very compact, has a 4-inch barrel, very light. The whole bottom half of the gun is composite. It only has 32 moving parts. It's just a phenomenal gun. You can throw this thing in the water and take it out and start shooting.
Great. Right, then it looks like we're ready to get started. I'm going to put on my ear protection here.
And I think I will do the same.
All right, sounds
and
good.
What's on my protection? I have.
Protect my eyes as well.
Yep.
This is the block of wood we're going to be shooting into. It's just above 5 kilograms. It's about 11 pounds, wood and clamps combined. All right, so Mr. DelTour is set up over here with the gun. And let's go ahead and do some physics. I think I just wet myself a little. Yeah. Yeah, that went in there. Want to do it one more time? Woo. I like that one. Second shot. Oh, can you see it in there? That went all the way through to the third plank.
And about halfway through.
About halfway through, yeah. That's very. What an impressive display of physics. And now for some fun, because here on Mr. Physics, we're all about fun. We picked up some 1-gallon jugs of water, and what do you think we're going to do with them? That's right, we're going to shoot them. All right, so first one to hit their jug wins. Okay, you ready? 1, 2, 3. I missed mine. You again. Well, that's it for Mr. Physics today. As we've seen with the conservation of momentum, momentum is a product of mass and velocity. So some things take the momentum well and the bullet stays in it. Some things are flimsy like plastic, the bullet goes right through it. Thank you for joining us. I can't think of the signing off phrase.